Hello everyone, welcome back. In today's video, we're going to build 10 practical hands-on Python projects specially designed for beginners. These projects are perfect if you have just started learning Python and want to turn your knowledge into something real and working applications. So without wasting any time, here's the list of the 10 projects we're going to create together in this video. Before we jump into the first project, if you're new here or if you find this kind of content helpful, please do me a quick favor, hit the like button and subscribe to my channel. It really helps me create more free tutorials like this one. Alright, now that we are all set, let's get started with project number 1. So first things first, we'll be creating a simple terminal-based calculator program. So for that, let's create a separate folder called 001.calculator. Then inside of that folder, let's create a brand new file for our Python file, and let's call it main.py. So in order to follow the best practices and write a clean code, I will be creating this main function, which will contain the main functionality of our program. Then I will define this main section. So let's say if name equals to main, I will be executing this main function. This basically says that if you're directly running this file, then proceed with this following implementation. Otherwise, just ignore this. So in this main function, what we'll be doing first of all is that we will be greeting the user. So let's say print welcome to calculator program, something like that. And after greeting, we will create an infinitely running loop using while. So while true, we will say inform the user what kinds of available options do we have in our program. So for that, we have to use print statement in order to display all the available options. So print, and I will use triple quotation marks in order to format my message nicely. Here I'll add new line character, and the first option that we can have is the addition. Basically, we will be able to perform 4 various kinds of arithmetic operations in our calculator program, which are addition, subtraction, multiplication, and finally division. So let's add commands to all of them. Second one, subtraction. Third one will be multiplication. Then fourth one will be division. Also, I want to add the fifth choice, which is going to be responsible for quitting the application, because as you can see here, we have an infinitely running while loop, and typically we should have some way to exit out of this loop. So for that, we will add the fifth choice, which is going to be exit. Then we have to prompt the user to select one of these options. So option will be equal to input, select an option. Now we have to check whether our option was a valid option or user has entered some kind of garbage instead of selecting the valid option from our list. So for that, we can just say if option not in this list 1, 2, 3, 4, 5. Those 5 digits are our available options. That's why that is going to be working all right. This if statement check. If our option is not in that string, we will say print invalid option, exclamation mark, and continue to go to the beginning of our loop. Then if our option is equal to 5, we want to say break in order to quit our application. And after that while loop, we will say some kind of goodbye message like thanks for using calculator, something like that. And if our option does not equal to 5 and if our option is valid, we have to now perform the arithmetic operations. So in order to perform arithmetic operations, we have to get 2 numbers from the user. So let's say number 1 equals to input, enter number 1, just prompting the user, then number 2 equals to input, enter number 2. These numbers should be whole integer numbers or some floating point numbers. So in order to check that, I will be creating my own custom function, because Python does not provide us built-in functionality for that check. So the name of my function is going to be called isFloat, and I'll accept one string. So let's say string, maybe no, I think that name will be confusing, so let's say something like target, which is going to be of data type string. And to check whether our target is of floating data type, I have to use this try catch statement. So I'll say but I'll just attempt to convert this target into a float. If it does not result in any kind of error, I'll just return true. Otherwise, I'll return false, because our program was not able to convert that target string into floating data type, which means that it cannot be converted to float. So here, in order to validate my two numbers, I have to check if not is float number 1 or not is float number 2. I will say print invalid input, then continue, similar to this statement. Otherwise, if my numbers are valid, I have to now identify my current choice, my current arithmetic operation that has been selected by the user. For that, I can use traditional if statements, but there is not going to be very clean code, and that's why we can use a modern alternative which has been provided by Python, which is a match case. So we have to say match and provide a variable that we are trying to check. In our case, that is an option variable. So the first case is 1. If it equals to 1, we will print an else statement. Here will be number 1, then plus our number 2. Then the result will be number 1 plus number 2. Otherwise, alternatively, we could say result. You could create a result variable and assign it to the resulting addition operation, and just specify result here. It doesn't matter. The choice is totally up to you. This can be implemented in a wide range of ways. So result is number 1 minus number 2, because the second operation is subtraction in our list. Then similarly, let's provide this output print statement, and instead of plus we will have minus here. Then let's copy this in order to increase my speed. Then final one is 4. This is going to be 3, and the third one is multiplication, so this will be multiplication sign, and here as well this is division and division. Also, there is one little catch in our division. The user might accidentally enter 5 for the first number and 0 for the second number, and such action would result in a devastating error in our program. That's why we have to account for that, because numbers cannot be divided by 0 in math. That's why we have to check that by using a simple if statement. So if number 2 equals to 0, we will say print cannot divide by 0, and just say continue. No need to say continue. Otherwise, if that is not the case, we'll say else and provide these operations in the else case. Alright, that should be it for our simple calculator program. Now let's try to run it. So I'll save it first of all and open up my terminal. So first of all, I'm going to cd to my appropriate folder in which I'm currently working in. So calculator, then let's run my main.py file, python main.py, and it hasn't resulted in any error, fortunately. So let's try to first of all pick this addition operation. So let's enter 1, then two numbers, 20 and 8. Oh, it gave us 208 instead of 28. So I know the issue. Right now our two numbers are of string data type, and number 1 in our case was 20 and number 2 was 8, and by basically adding them we were just combining those two strings, which resulted in 208. But that's why we have to convert those two numbers into floating point data types before proceeding with our arithmetic operations. So let's say number 1 and number 2 equals to float number 1, then float number 2. Alright, that should be working quite well. Now let's break that and try to run it one more time. So addition 20 and 8. Now it works as expected. Now let's try to check subtraction. 7, then 9, it should give us 8, yeah, 8. Then multiplication, 5 by 9, 45. Division, let's say 14 by 7, 2. Let's enter some kind of invalid option. For example, this garbage string, it says invalid option, safely handling that issue. Then division, let's provide 0 as a second number to check if our guard check here is working as expected or not. So first number is going to be any number. For example, this large number. The second number is going to be 0, and it says cannot divide by 0. All right. Now I want to check one thing as well. One more thing. So let's select addition. I want to type in some kind of garbage here, yeah, and some digit here, and it should say invalid input. Yeah, that is working quite well, as you can see. Now let's say exit in order to exit our calculator program, and it says thanks for using calculator and gracefully quit the program. So that is it. That's a simple calculator program in Python programming language. So in this section we will create a simple random number guessing game in Python. So let's create a separate folder for that and give it name 002, then random number guessing, and that should be it in my opinion. Let's create a new main.py file inside of that folder, and we can collapse this sidebar, this explorer. So inside of this main.py file, we first things first have to import this module called random, because we'll be working with random numbers to generate a random number between 0 and 100. As always, we will be creating this main function, which will be responsible for the main flow of our program. For now, I'll leave pass here because I'm not writing the implementation of this function yet. Below this function, I have to create this name main block, and inside of that I'll call this main function. So inside of this main function, I first things first want to greet the user by saying welcome to random number guessing game or something like that. Welcome to random number guessing game. Let's now also give the instruction to say the user that he or she has to guess a number between 0 and 100. So print guess a number between 0 and 100 ... Then I will say here running variable will be true, and while this running variable is true, I will be running this while loop infinitely. So inside of the while loop, I will need to generate a random number. So in order to generate a random number in Python, you just call this random module and access a function called randint inside of it. And inside of this function, you have to pass the lower boundary and the upper boundary of the number of the range in which you want to, in which your number will fall. All right. So the lower boundary in my case will be 1 and the upper boundary will be 99. But those both two numbers are inclusive, as you can see here. That's why I'm saying here 99 instead of 100, because I don't want to include 100 here. Now let's assign that random number inside of a variable called random number. Then we will say guess a number in order to indicate that we have already generated this random number. And here we will create another while loop, while true, in which we will keep asking the user to take a guess until they eventually find the random number. So let's say guess will be input take a guess. All right, then I have to convert this guess number into an integer, because right now it is of string data type, and to be able to work with it nicely, I have to convert it into a string, into an integer, sorry. So and that is quite vulnerable piece of code, because user might accidentally type in some non-numeric data inside of this input. That's why we have to account for that error state as well. For that, we can use this typical try-catch block which we have discussed in the previous section, as you can see here. But here we were working with float, but working with integer is better, is easier. We just have to say int, and except if it results in an error, we will say print invalid guess, then continue in order to start this loop and start the execution of this loop from start. Then if we will manage to convert this guess into a number, into a digit successfully, we will try to check if this guess number, if our guess is equal to this random number. So if guess equals to random number, we will say print correct, then if guess is greater than a random number, we will give a hint to the user saying that this is too large, and else we'll say too low, like this. Okay, also what I want to do is I want to track the number of attempts it took for the user to guess that random number. For that, I will here create a new variable called attempts, and initially it will be equal to 0, and I will be incrementing that attempts variable here, maybe here, attempt plus equals to 1. And finally, when the user finds the random number correctly, I want to inform the user about how many attempts it took for him to find that random number. So for that, I can use fstring and say it took you this much attempts to find. That's it. And after this while loop, I can ask the user whether he or she wants to play one more time or not. So I can say choice maybe equals to input. Do you want to play again? Yes, no. And I have to check it if it is equals to, no, I forgot break statement here, because we have to be able to somehow exit this infinitely running while loop. That's why this break statement here is quite crucial. So if choice dot lower equals to no, I will set my running variable to false, which will exit this loop in the next iteration. So let's try to run this program, but before that I wanna say maybe new line character here, maybe, or not. Let's try to run it without that new line character, and let's see what we will get. So let's first of all move to this random number guessing game directory here, so cd 002, and then we can say python main.py and take a guess. Let's choose the middle number, which is 50, too large. Okay, 25, too large. 13, too low. 17 maybe, or maybe 18, too low. 22, too large. 20, too large, and it is 19 then. Yeah, 19. Do you want to play again? Let's say yes. All right, guess a number. 50, too large. 25, too large. 16, too large. 10, too large. 5, 8, 9. All right. 50, too large. 25. It's 1, which is remarkable. Let's play one more time because I want to get a number which is greater than 50 in the beginning. So unfortunately I'm not getting that number, but let's keep trying. Set 27. Okay, let's play again. 50. I'm not getting that number which I want, but I have chosen a number between, I'm generating a number between 1 and 100, but let's keep trying. Okay, yeah, finally we got a number which is greater than 50 and less than 100. 75, 60, 64 maybe. Okay, 57, 50, 53, 55, 54. All right, now let's say no, and it should exit. Yeah, but before exiting I want to say some kind of goodbye message here, probably here. Yeah, print thanks for playing, something like that. And before that, guess a number, I want to say like this. Okay, in order to make a formatting a little bit more appealing. All right, now let's try to run it. All right, as you can see, we have a new line here, new line break, which makes the UI much more satisfying and pleasant. Take a guess. 50, too large. 25, too low. 37, too large. 28, 30, too large. 29, yeah. Now let's say no, and we have here thanks for playing message. All right, that's it for our simple random number guessing game that we have created in Python programming language. So in this section of our video, we're going to be creating a comprehensive to-do list application in Python programming language that is going to be a console-based to-do list application with its built-in memory. We'll implement a memory using a file. We'll use CSV files to store all the to-dos that we have created. So that is going to be a slightly bigger project with approximately 150 lines of code. So let's go ahead and create it. First of all, the file, appropriate file for it, to-do list app, then Python file inside of it. So inside of this file, let's import CSV and as usual create our main function. So it will be pass here for now, then our main block here at the end, then main function like this. Then in the main function, what I want to do is I want to first of all greet the user by saying welcome to to-do list app, then exclamation marks, then maybe print these decoration signs, to make the visuals much more appealing. Then after that I will create a while loop, and I want to display all the available possible options that I have using three square break, those quotation marks. First option is gonna be so basically I will have like 5 operations to which are going to help me to work with my to-dos. So the first one will be view to-dos, that is going to display all the to-dos that I have. Second one will be add to-do. Third one, delete to-do. Next one will be mark as completed, then unmark as completed, then finally the sixth one will be for exiting. Alright, then I have to get the choice from the user by using an input, select an option, and I have to check whether I have to validate my choice, whether it is valid or not. So the first check is gonna be like this: if not, choice in this string. I have used, by the way, this mechanism, this trick in my calculator, like here. If you're not familiar with that, just you can check that out. Here I will say print invalid choice, then say continue to continue my infinite while loop. After that I will try to convert this choice into an integer, because right now it is a string and I don't want to work with strings. So let's say try choice equals to, no, I think we don't need try statement here, because here we have validated that our choice is such a digit, so we can feel free to convert it into an integer and it will not result in any kind of error. So choice equals to int choice. Then I want to use my match statement, then check for all the possible cases. So here, if the first case has been selected, I want to call this function handle view to dos in case 2. By the way, I have not created this function yet. I will be creating it just in a second. Let me first of all implement those case statements. So case 2, handle add to do. Case 3 will be handle delete to do. Case 4, handle mark completed. Then case 5, handle unmark completed. Then case 6 will be, no, should I say like no, if case 6 I want to just break out of the loop, and after we break out of the loop I want to display such bye-bye message to indicate that this program, this application is trying to quit. So quitting ... and I'll say time.sleep 0.4 and import that time module here. This time.sleep basically stops the execution of our program for 0.4 seconds. So we have to specify here seconds, and 0.4 means 400 milliseconds. Alright. Then I have to now create those 5 respective functions at the top of my program. So let's go ahead and create them. So handlers, those are going to be the handlers, main function. I'm trying to add comments to make my code a little bit more understandable for other people and try to just follow the best practices. So handle view to do's is my first function. Have I spelled it correctly? Yes. Then the second one, def handle add to do, like this. Def handle delete to do was the third one, yeah. Pass handle mark completed. This was the first one, right? Yeah. Then let's copy this instead of typing it out from scratch. All right, but before implementing those two functions, I have to also implement two utility functions that I will need throughout my implementation of those 5 functions. So utility functions, first one will be load to-dos. This function is going to be fetching all the to-dos from my CSV file, and I need to have one respective function called save to-dos pass. This is going to be saving the to-dos by writing all the to-dos to my file. Also, I want to create a separate class for my to-do in order to make the process of interacting with my to-dos much more straightforward, So to-do dev init. Then I will have self.id. All the to-dos will have their unique identifiers for me to be able to work with them efficiently and in a much more practical way. So it is going to be id, which is going to be coming from the parameters. Then title will be string, then completed will be bool, and default value of it will be false. Also, the id needs to be integer. All right, I'm just annotating them to produce much more productive, much more efficient code. Then title will be title, self.completed will be completed, and that's it. Yeah. Let's add comment here, to do class. Then I want to create 2 variables in the global scope of my program. The first one will be a constant called file name, which is going to be storing the file name of my CSV file, which will be containing all my to-dos data. So its name going to be todos.csv. Then I want to have a list of my to-dos, which is going to be of type list to-do. It is going to be empty at the beginning of our program. Now let's go ahead and implement this load to-dos. This part of my code is error prone, that's why I'll be wrapping it inside of my try catch statement in order to handle error gracefully without terminating my program. So I'll say here with open my file name in a reader mode as file. This is how I will be opening a file. I will be opening it in a reader mode because I'm trying to read the to-dos in order to load them. Then in order for me to read data, the content of CSV file, I first of all have to create an instance of a reader of this CSV module that I'm importing here. So let's create one. Reader equals to csv.reader, and I have to pass my file for it. File. Then I think reader dot I think we have to iterate through it. For to do in reader, to do is a string, right? No, to do is a list. So in order to can I use list comprehension in order to make the process much more efficient? So to do is equals to to do, then for to do in reader. So to do right now is a list of strings, as you can see here. Then in order to create an instance of my to do here, I have to say to do at the index of 0 in order to access this ID. Also, I have to typecast it into an integer because right now it is a string. Then as a second argument I have to pass string title, then finally second one equals to true. Alright, now also if you pay attention, you will notice that this to-dos variable is being created locally and it is not directly affecting my global to-dos variable. That's why we have to use this this statement global to-dos for our redefinition here to affect our global variable here. That's an important part. We are not using object-oriented programming mechanism here, but if we were to use one, our program's flow would have been much more efficient and cleaner. We wouldn't be using such global statements like here. So for the except clause, I will say print error loading to-dos, something like that. And that's it. Yeah, I think so. So now let's go ahead and implement the functionality for saving to-dos. So it is going to be inside of try catch statement as well, because it can potentially throw some kind of error for us. That's why we have to be able to handle that error gracefully. File name, we will be opening it in a writer mode because we will be writing some content to our file. So as file, then similar to here, we have to create a writer object of CSV. So writer equals to CSV.writer file. And then how I'll be going to be writing. We can use write row or write rows. Let's utilize a loop and combine it with write row, because it is going to be giving us much more flexibility for us to work with individual to-dos. So for to-do in to-dos, here we don't have to use global statement because we are not trying to change the value of that variable. We are just trying to access the value of that variable. So here what I'm going to say is that let's say write row, and it expects a string from us. No, it expects a list from us, right? So let's pass a string to it. So it is going to be todo.id, then todo.title, then todo.completed. Alright, that should be it. For my save to-dos file, save to-dos function, in the except block, I need to say print error saving to-dos, and that's it, maybe. Okay, in my handlers, now let's go ahead and implement my handlers. In my first handler, which is view to-dos, handle view to-dos, I will just basically fetch all the to-dos that I have here and display them using a loop. So first of all, let's inform the user that I'm about to display all the to-dos. So to-dos, maybe use some signs for decoration purposes. 1 2 3 4 5 6 7 8. Okay, print. Now I want to display the total number of to-dos that I have. Or before that, I have to load to-dos in order to fetch the most up-to-date to-dos that I have in my file, in my kind of database. Number of to-dos, then len to-dos, then use my for loop in order to display all the to-dos, then print f statement. Probably I have to use enumerate in order to access an index or not. No, I don't need an index. I just can say todo.id, then todo.title, then todo.completed. If todo.completed, I want to use some tick here, then else it will be cross. Let's grab those two icons from the internet. Alright, I have brought those two icons from the internet, then that should be it for the mechanism of printing the to-dos, of viewing all the to-dos that I have. Then the next handler that I need to implement is handle add to-do. Here I want to get only one information from the user, which is the title of the to-do. So I have to use only one input statement. So title is going to be equal to input enter to-do title, like this. Then I have to create a to-do equals to to-do. Then I have to pass an ID here, to-do new ID, then title. Then I don't have to specify completed because it is by default equal to false. So now I have to figure out how I will be generating a unique ID, which is going to be the minimum possible value. For that, I want to create a separate function, def generate ID, then current result ID will be 1. Then I have to create a list of all the sorted IDs of the available to-dos. So sorted IDs will be sorted, then list comprehension, then ID, to-do.id for to-do in to-dos, like this. Then I want to iterate over all the sorted IDs. Sorted ID equals in sorted IDs. Then what? If result ID equals to sorted ID, I will increment my result ID by 1. Then elif result ID, sorted. If sorted ID is greater than result ID, I will say just break, because it means that I have already identified the minimum possible valid ID for my to-do. Then I can finally say result ID here to return that ID. Also, let's indicate that it is going to be returning an integer value. So let's now grab that new ID using that newly created function of mine, generate ID. Then that seems alright. Now I have to say to-dos.append to-do. That's it. Then I have to save my to-dos, right? Then let's inform the user that the to-do has been created successfully. Created to-do successfully, like that. Then next function that we have to implement is handle to-do, handle delete to-do. So for this specific function, we have to get the valid to-do ID from the user. So let's get target ID equals to input enter to-do ID to delete, like this. Then I have to try to convert it into an integer. Try target ID equals to int target ID, except print invalid ID, then just return, right? After I have converted it into an integer, I have to check if the to-do with such an ID exists in my list here. To do that, I have to use a loop once again. So for to-do in to-dos, if to-do, right now I have grabbed the unique identifier of a to-do from the user, and here I have to identify the current position of that to-do in my list in order to be able to delete it later on. So here, that's why I have to use a enumerate function and grab the current ID of the current to-do that I'm working with. So if to-do.id equals to target ID, I wanna say let's create a separate variable which is going to be holding the value of current. list index maybe, which is going to be equal to -1 initially. Then if I find the appropriate to do, I will assign my list index into I. Alright. Then I have to attempt to delete that to do. Delete a to do at this list index. So that should be fairly straightforward. I have to just say my to-dos dot pop, right? Yeah, pop, and specify my index. Then print f string to do with id list index has been deleted successfully, like this. Then I have to say save to dos, and that's it. Also, I think I can move those two statements here and just remove that and replace them with this ID that I have. Alright. That should be working fine for my delete to do function. Now the similar mechanism is going to be applying for my two other handlers, which are mark completed and unmarked completed. So I can just copy those lines of code and pass them here. But I'll be adjusting it a little bit. So it will be enter to do ID to mark completed. Then instead of popping it, I have to say to do's at this specific ID, then completed equals to true. To do with ID, this has been marked as completed. Save to do's. Alright. Now let's copy this one more time and paste it here. Enter to do ID to unmarked completed. Then here complete status will be set to false. Then it will be unmarked as completed. Alright. Now, in my opinion, this should be working quite well. This should be it for our program. Now what I want to do is I want to run this program in order to check whether it's working correctly or not. So let's open up the terminal for that and run my application. So cd to 3, then python main.py. Then let's view to-dos first things first. And as you can see here, I received some kind of error. I think that error occurred because I don't have any file right here. And to do that, I have to say load to-dos right here. So let's try to run it one more time. No, it resulted in an error one more time. Save to-dos, then write to-dos. It should work now. Yeah, as you can see, our file has been created here. Our plain new to-dos.csv file. Now let's run our application and see all the available to-dos that we have right now. And as you can see, we don't have any to-dos right now, unfortunately. So that's why let's create a couple of to-dos. Select 2, enter to-do title, do push-ups maybe. Then let's a couple more to-dos in order to fulfill our list. So the title of this new to-do will be read a book. Let's add one more to-do. Do groceries. Then the final one, code new app maybe. Something related to programming. Now let's try to view all the to-dos that I have in my database. And I have 4 to-dos, as you can see here, with valid IDs representing each of the to-dos. And all of the to-dos are now uncompleted, as you can see, because I haven't completed them yet. So if I, for example, enter some kind of invalid option, it will say invalid choice. but I'm missing an exclamation mark. Unfortunately, I forgot to add it. So let's try to complete a couple of to-dos. So let's select the option number 4, and the to-do ID is going to be 3. All right, now let's complete the to-do with ID maybe 1. Then let's view all the to-dos. As you can see, now those to-dos have been completed. If we took a look in our file, we would see that those two have statuses true because we have completed them. Let's assume that I don't like programming, which is unrealistic totally. So by that I can delete, by assuming that I can delete that to do with the ID number 4 because I hate programming, presumably. So let's delete to do with the index of 4, and it has been deleted. What? Whose ID 3 has been deleted successfully. Oh, I know why this issue is occurring. Now if we take a look at our to-dos, we will say that to-do with ID 4 disappeared, and let's fix that error real quick. Here, instead of specifying I, we have to say target ID. Alright, the same applies here to here as well, and here as well. Now let's run our application from all over again. Now view to-dos. As you can see, we don't have any to-dos. Oh, all to-dos have been cleared. I know why. Because first of all, we are trying to write all the to-dos. I tried to write all the to-dos because initially my to-dos list was empty. That's why the save to-dos function cleared all the to-dos that I have. So I have to remove that line of code as well. My bad. Now I have to add those to-dos from all over again. Do push-ups, then one more, code new app, one more, read a book. Alright, now let's complete a couple of them. For example, 1, then 3, yeah? Now those two have been completed, and let's try to uncomplete this third to do. So 5 is going to be my option. Then the ID is going to be 3. Then to do with ID 3 has been unmarked as completed. Now it is unmarked. Now let's add one more to do. Hi. Then view. Then try to delete the second to do. Alright, to do. Now it is working as expected, as you can see. Now if I try to add one more to do, it should appear, it should spawn with an ID of 2 because ID 2 is the minimal valid to do ID that I have. So let's go, and title is gonna be jump, maybe some abstract to do title. Then yeah, as you can see, it has an ID of 2. Now let's try to exit our program by selecting 6 option, and as you can see, it displayed that message quitting, and it stopped the execution of our program for approximately half a second because of that sleep statement that I have added at the bottom of my application. Alright, now if I try to run my application one more time, I should ideally have all the to-dos displayed from the scratch because I am saving basically those to-dos in my file. So I should be able to see those to-dos initially if I have not messed up anything. So let's run my program, and view to-dos. Yeah, I have all those to-dos saved in my memory. So this is it for our to-do list application. This was a comprehensive to-do list application with a built-in memory, which we have implemented in Python programming language. As you can see here, we have organized all the different kinds of functionality into separate functions in order to keep our code clean and neat. And we also accounted for all the possible errors to maximize the safety of our program. I hope this mechanism, this approach is clear for you. And this program was a little bit more complicated compared to other projects that we were creating. So that's it for our to-do list application. So the next project in our list is a random password generator. We'll be able to generate a random password containing uppercase letters, lowercase letters, digits, and punctuations, depending on the user's requirements. So let's create a separate folder as usual, random password generator. Inside of that, let's create as usual main.py file and collapse our sidebar. In this application, we should import 2 or 3 specific libraries. The first one is going to be string. I'll explain you why we need this string later on. Then we need this arg parse in order to be able to parse command line arguments with ease. Then let's create a typical main function, which we were creating in the previous projects. Main, then call our main function. Alright, then in our main function, we want to create an instance of this arg parse argument parser. So parser equals to arg parse dot argument parser. Alright, then description will provide an additional description in order to make our program much more diverse. So description is going to be random password generator. Basically, this argument parser is an interface which provides a wide range of facilities for us to be able to work with command line arguments. So it is going to be much more convenient for us to work with arguments. Then the first argument that I want to specify here is going to be the length of a password. So in order to create such an argument, we have to say parser.add argument. Then name of that argument is going to be length, and this is going to be a must-have argument. So the user must provide this argument to be able to proceed with the application flow. Then it is going to be of type integer, because length of our password is going to be integer, numeric data type. Then helper message will be the length of the password, something like that. Then I want to create 3 additional arguments which are going to be responsible for whether we are going to be adding uppercase letters, digits, and punctuations. So parser.add argument, I will specify dash and u. This dash means that this argument is optional. We don't have to specify it. Then this is going to be upper. This is the name of that argument. Then action will be store true. And then helper message will be include uppercase letters. Then similarly, we are going to be making parsers for digits. So D digits. Then this is going to be punc, short for punctuation, and P here. Include punctuations here. Then here include digits. Okay. Now in order to parse all those arguments that we have specified, we should say parser.parse args, like that. And now we can use those 4 arguments that we have specified. And we don't have to validate anything because argparse interface provides us a built-in functionality that handles all the validation processes. Now we can access those variables by using our resulting args variable, and print them to the console. For example, you can say args.length, args.upper, for example, then args.digits, args.punc. Then let's use print statement in order to print them to the console. And let's open up the terminal and run our application to see how those arguments are working. So cd to our respective directory, then say python main.py, and we received an error. Alright, I'm missing those dashes here, so let's provide them and clear, then try to run it. So we received an error saying that we are missing a required argument, which is length. Our length argument is required because we haven't added that dash here. If we were to add that dash here, we would be able to run our program. It resulted in an error because there should be 2 dashes here. Now let's finally try to run our application, and we received none, false, false, false. So we haven't provided this length, that's why it is set to none right now. If you were to remove that, our program will ask us to specify that required argument. So let's run it, and it says required argument is missing. So let's provide that required argument, which is, for example, 12, and it says here 12, as you can see. Now if we were to type in some kind of invalid data, for example some kind of text, it will result in an error, right, saying that it is an integer value, expected an integer value, and receive some kind of string value. So that is working very fine, very well. Now let's move on and create a functionality for generating passwords. So generate password, then we want to accept the length of our password, which is going to be integer. Then we want to receive 3 boolean arguments for whether to include uppercase characters, digits, and punctuations. So upper bool, then digit bool, then punc bool. This is going to return us a string, so let's annotate that. So right now our combinations of all the characters that we can use will be string.ascii lowercase. ASCII lowercase is going to give us all the lowercase letters in our English alphabet as a string, and we can add, if our upper boolean is set to true, we can add string.ascii uppercase to our combinations to include English uppercase letters as well. Then similarly we need to do such mechanism for digits, string.digits, then if punc combinations plus equals to string.punctuations, like that. Also we need to import a random in order to be able to generate a random password. So we can return this .join, then choice random choices. It is going to return us a list, right? Then population is going to be our combinations, this first populations, and k is going to be the argument that specifies how many choices, the number of choices that I want to make. So k is going to be length, and that should be fine for our generate password function. Now let's try to use that function here. Password equals to generate password, then args.length, args.upper, args.digits, args.punc, like that. If I try to use such an argument, will it work? Args. I'm not sure about that. We can try that in order to make sure that that mechanism, that approach works as well. So let's now print our password. Password will be like that, then format, specify our password. This is another way of formatting text. unlike this prior traditional approach of this f string, we can use this formatting as well. This is slightly different approach. Yeah, now let's try to run our program and see if it generates a random password without any errors. So let's run the program and specify the length of our password, for example 12, and we indeed get our password. Now let's try to specify uppercase letters as well, and it includes uppercase letters as you can see here. Now let's try to add digits as well. Then for some reason we didn't receive digits. Maybe that was the result of randomization. Yeah, we indeed received digits as you can see. If we remove this uppercase, we would receive even more digits. Yeah, as you can see here. So let's add upper and punctuations as well. And this is the resulting password as you can see. Now I wanted to check whether that kworks argument works here. Args. Then let's try to run it, and it didn't work. Alright. So let's go back to our previous approach. Alright. Now it should work. Okay. Password is a length of 12. And our random password generator program is indeed working very fine. So this was a relatively small program that we have implemented in Python. Compared to our previous to-do list application, this was significantly much more straightforward. Yeah, this is how you implement a simple random password generator using command line arguments in Python. In this section, we will create a simple unit converter application. This is going to be a very helpful practice for us, in which we will consolidate our knowledge in such command line arguments which we learned in the previous section. So this is going to be a fairly straightforward project, so let's implement it really quickly without spending too much time on talking. Unit converter, then main.py file as usual. In this tutorial, in this section, I want to omit the usage of this main file, main function, in order to show that we can create an application without using main function. So as usual, we'll import argparse in order to work with command line arguments, and here we'll say parser equals to argparse.argument parser. Then the description will be unit converter, like that. Then we have to say we have to specify only two parameters, only two arguments. The first one will be the value of the value that we want to convert, and the second one will be the information which helps us to identify to which unit we want to convert, for example, from miles to kilometers or from kilometers to miles. Add argument, then it is going to be value, then help will be do I need help? I need float data type. I don't need any helper, because in help I don't know what kind of information or what kind of message we need to specify in help. That's why I'm going to abandon that part. Then second argument is going to be km, then here it will be kilometers. Then type will be, no, we don't have to say any type. Action store true. Then help will be convert miles to kilometers, like that. Then similarly, let's specify the second one, which is going to convert kilometers to miles. Then it needs to be miles. Then this one will be just m. Then I have to parse my arguments. So arguments equals to parser dot parse args. Then I can say check, I can say if argument.km, not kilometers. If this kilometers is specified, then it means that the user wants to convert from miles to kilometers. Otherwise, I can say elif arguments.miles. It means that the user wants to convert from kilometers to miles. Then a result is gonna be arguments.value. In order to convert miles to kilometers, I have to divide it by 1 and 6, right? If I'm not mistaken. And here I have to say arguments.value times by 1.6, right? Because miles are greater than kilometers, right? So here I have to say print in order to display the message, and I will use dot format in order to learn how to use this format specifier as well instead of this f string. Then I will say this much miles equals to this much kilometers. So miles will be arguments.value, right? Then second one will be result. Then let's copy it because this part is gonna be similar, but instead, that's all right. It should be kilometers here and miles here. All right, now let's try to run this application. So cd 005, then python main.py. If I run this like that, I should genuinely right now receive an error because I'm not providing this required parameter, which is value. So if I enter, I will get an error, right? Then let's specify that value. For example, 20 kilometers or 20 miles, and do not specify any other parameter here. If I run this, nothing should happen because those if statement blocks have not been triggered. Yeah, nothing goes. If I now specify km, meaning that I want to convert miles to kilometers, I would get something like 16 or 15, something like that. Yeah, 11, 12. I got 12. Then if I specify 100, I should get... Now if I wanna, let's say if I wanna convert 100 kilometers to miles, and I should get 160 miles as a result, yeah. Then let's try kilometers like that, and I received 62.5 kilometers. This is an approximate value. This is not 100% accurate calculation. It is because to get 100% accurate calculation, we have to multiply it by 1.6 and something like that. And I have got rid of those fractions in order to make it much more appealing. That's why this is not 100% accurate. So that's it for our simple unit converter application. We used argument parser one more time here in order to strengthen our knowledge in this specific library. In this section, we will implement a simple dice rolling simulator. So it is going to be yet another interesting practice for us to learn arg parser. So let's go ahead and create one separate folder, dice roller, something like that, rolling simulator maybe. Then inside of that, I'll create main.py file. Then we need to import two things. The first one, arg parser. The second one is random in order to be able to generate random dices. Then here, let's say if name equals to main, I'll call my main function over here. Then inside of this main function, let's create as usual our parser, which is going to be argparse.argument_parser. Then description will be dice rolling simulator, something like that. And then I'll have only two specific arguments for my parser. So add argument, then name will be, first one will be n, which is going to be responsible for the number of rows I want to make. So it is going to be integer. Then default will be 1. Then help will be number of roles, something like that. Then parser dot add argument, our second argument, let's call it k, and type of it will be int as well. Default will be 6, and this is going to be number of sides of a die, number of sides, something like that. Then I can use in for loop for I in range. No, first of all I have to parse my arguments. So args will be parser dot parse args. Then for I in range args dot n. Then I have to calculate the total in order to display it to the user and at the end. So total will be 0, and let's inform the user that we are displaying our rolled dices. So add these signs for decoration. Dice rolling, maybe 1 2 3 4 5. Then here I want to say current will be random.randint between 1 and args.k, right? Then I want to say total plus equals to current. Then display it nicely using an f string. So this is going to be roll number this, roll I plus 1. Then it is going to be my current, right? Current. Maybe I can add dash here as well for decoration. And at the end, let's print the total, then total, like that. Now let's try to run this application, see what we get. So let's cd to 006, then python main.py, to run that file, and by default I had only one roll and number of sides was 6. That's why I got this result. So if I run it, I'll get a random different number of a roll of a dice, as you can see here. Now let's try to specify number of rolls, maybe 3, the number of sides, maybe 10. I'm missing those n and k specifiers. Now it works successfully. As you can see, I have 3 rolls and all of them have the random sides between 1 and 10. So if I run it multiple times, I'm going to be getting different dices, as you can see. So yeah, if I add 100 here, I'll get even larger numbers. Yeah, this is how you implement a dice rolling simulator in Python programming language. In this section, we'll create a simple random quote generator. As you can see, I've already created this quotes.txt file that contains 20 different kinds of stoic quotes. I've got them from AI. Those are simple stoic quotes, and we'll be fetching random quotes among those quotes in our program. So for that, we have to import a module called random, and let's create our typical main function. Then this if name block, if name equals to main. Then I'll call my main function up there. Then in my main function, I want to get, first of all the list of all the quotes that I have. For that, I can create another utility function in order to make my code, in order to keep my code organized and neat. Fetch quotes, something like that. And let's create that function, fetch quotes, like that. And it's going to return us a list of strings. So with open quotes.txt in a reader mode as file. Then my quotes will be what? A list comprehension, then line.strip for line in my file, right? Then I can return my quotes if I'm not mistaken. Yeah. Then I've successfully fetched my quotes here, and my quotes here is a list of strings, as you can see. Then I can get random quote among those quotes. For that, I have to say random quote, then random dot choice, maybe choice quotes, like that. Then print random quote, maybe in lowercase 1 2 3 4 5. This print statement is just for decoration purposes, and quote is going to be just quote, maybe random quote, and that's it. Now let's try to run this application several times to see if we are indeed getting random quotes. So cd007, then python main.py, and yeah, the happiness of your life depends upon the quality of your thoughts. Then if we run it multiple times, we are going to get different quotes each time we run our application. As you can see, yeah, this is how you implement a simple random quote generator in Python. I'm storing all the random quotes, all the list of all the quotes in my quotes.txt file, but for the more advanced tutorial, I could have explained to you how do I fetch random quotes from the API, but that would have been a little bit more complicated. That's why I decided to stick to this approach. So yeah, that's it. So in this section, we'll create a quiz application in which we'll be able to see questions related to programming, then options for each of the questions. Then we'll be able to respectively select the answer choice, our choice for each of the questions. Then at the end of the quiz, we'll receive our conclusion, stating that how many questions we were able to answer. So let's create a folder for that, quiz application, then Python file inside of it, main.py. In this application, we don't need any kind of external libraries. We just need a large pack of our questions, like questions and options that are related to it. So questions is going to be a list, and I'm going to quickly create some questions related to programming. So first one will be which programming language Python has been written. In which programming language Python has been written. Then the second question is going to be which company originally developed Go programming language. Should I add the here or not? I don't know. What does HTML stand for? That question. Then who was the founder of C++? Then what is the first programming language? That is a quite controversial question as well. Most people say that the first programming language was assembly, but in reality it was Fortran. So most people confuse it. Options list is going to be a separate list that is going to hold options for each of these questions. For example, first two, I'll have exactly four options for each of the questions. That's why I will create four strings that are going to be holding the options, which are going to be responsible for the options of this first question. So let me quickly fill them in. So first one is going to be C++, then C, then assembly, then machine code. Some people might think that Python has been written in machine code, which is not true. So companies who developed Go programming language: Microsoft, then Apple maybe, then Google, which is the right answer, then Mozilla maybe. Mozilla also created Rust programming language. That's why some people might confuse them. Acronym of HTML. So the right acronym is Hypertext Markup language, and I want to fill those other gaps with some kind of garbage strings. So for example, high text machine language, something like that, some garbage like that. Then hyper tabular marking language or something like that. Let me make this M as uppercase. Then hypertext management, let's go with that one. Then the options for my first question: Guido van Rossum is an individual who created Python programming language. Then Dennis Ritchie, this guy actually created the C programming language, one of the most legendary programming languages in the whole history of human existence. Then Steve Jobs, who was the founder of Apple. And finally, the correct answer is Bjarne Stroustrup. I don't know how do you pronounce that word correctly, but in my opinion, it is Bjarne Stroustrup. So the last set of options that I want to create is Fortran, which is the correct answer, the first programming language, then C, then JavaScript, which is not an ancient programming language, which is relatively new programming language that has been created at the end, right at the end of the 20th century. So that's why it can't be logically the first programming language. Then the last option is assembly, right? Okay, then correct maybe will be, our correct list is gonna hold the correct indexes of correct options. For example, for the first question, the correct option is C, because Python has been created in C programming language. That's why I'm going to add index 1 in here. No, not 1 but 2. I want to use 1 based indexing here instead of 0 based indexing, because that is going to be much more appropriate for user to interpret, because ordinary people do not understand 0 based indexing that we typically use in programming. That's why for user friendliness I'm going to stick for 1 based indexation. Then it is going to be 3 because Google created Go programming language. Then 1 hypertext markup language. Then 4 Bjarne Stroustrup, and finally 1 Fortran. Then let's create our main function as usual, and I'm gonna say pass in here. Okay, then if name equals to main, and our main function here, like that. So in our main function, I wanna first of all greet the user, print out some kind of message for decoration purposes, and maybe I can add equal signs here, 1 2 3 4 5 6 7 8 9 10. Then welcome to quiz or something like that. Then let's copy it, right, put it here. Then I want to keep track of the total correct answers that the user got. So for that I'm going to create a new variable, correct count, and it is going to be equal to 0 initially. Then I'm going to iterate over all the questions that I have using my range. So len questions, then print f string 1 2 3 4 5 6 question I plus 1 to indicate the current question, the number of current question, 1 2 3 4 5 6. Then I want to display the actual question, print questions at the index of I. That is going to get me the current question from my list that I'm working with currently. Then typically ideally I want to display all the options that are related to specific questions. For that I have to use inner loop for j in range 4. I'm saying 4 here because I will have 4 questions corresponding to each of the 4 options corresponding to each of the questions. So I'll use f string here as well, then j plus 1 to indicate the current number of the current option, sorry. So closing bracket. Then I have to get the current option. For that I have to use some mathematical operation, math calculations. So I times by what, 4, then plus j. That should work if I have not messed up anything. Then I have to get the answer from the user. Answer is gonna be input and answer maybe. Then I have to convert that answer into an integer. Answer equals to int answer. Then accept. I wanna say print invalid answer. Then say just exit to quit my application by terminating it. I'm using this try catch block because user might accidentally type in something non-numeric. That's why I have to account for that error gracefully. Also, I could have used if statements. For example, answer is digit. I had some kind of method here, something like that. Is digit. Do I really have that? Python. Then str.isDigit. Oh, is digit. 1.isDigit. It's true. Then if I pass in some kind of non-numeric value, it is going to say false. Yeah, that's exactly what I wanted to say to you. Exit and exit one more time. So you could use this alternative or try catch block. So let me stick to this approach because we have already familiarized ourselves with try catch block, and let's learn some other method of handling errors. So if it is going to be the case, I'm gonna print out invalid answer, then say exit to terminate the program. If I say here continue, it will go to the next question instead of returning to the same current question. That's why I have to say exit here in order not to mess things up. Then I have to check if my answer equals to the correct option here that I have in my list. And in order to check that, I have to say correct answer is gonna be correct, right? Correct, and at the index of I minus 1. No, not just I, because I gives me the current index of the current question that I'm working with. That's why that should be working quite well. Then if my answer is equal to correct answer, I'm gonna say print correct, and that's it. Then maybe increment my correct count plus equals to 1. Else I'll say what? Else I'll say print incorrect. Then I'll display the correct answer to the user so that user can familiarize himself or herself with the correct answer. The correct answer is, and then how can I get the correct option here from correct option from options list? I should use similar mechanism to here. Where was it? Similar mechanism to here. And I'm missing options here. Fortunately, I noticed that. And I have to use the similar mechanism here. I times by 4, then plus correct answer minus 1. I have to say minus 1 here because my correct answer is tracking the correct answers in one base indexation, as I said to you earlier. That's why I have to subtract 1 from here in order not to receive index out of bounds error or some kind of invalid behavior. So after I quit my for loop, outer for loop, I will say I'll inform the user the number of correct answer he or she got. So n and maybe equal signs, a bunch of them. Maybe that's going to be enough. Then I'm going to say f and what? I have to display the number of total correct answers that the user got. So that's why I can say correct answers and correct answers out of len of questions, like that. That's going to be working very well. quite smoothly. So let's try to run that application. First of all, cd008, then python main.py, and in which programming language Python has been rewritten. It has been written in C. What? Invalid answer. Incorrect. No, if it is not a digit, then I have to convert it into answer equals to int answer. Now it should work. My bad. Now let's select 2 and it's correct. Which company originally developed Go programming language? Let's say Apple has developed Go programming language, and correct answer is Google. As you can see, my current option was incorrect. HTML, what does HTML stand for? Let's assume that I don't know the acronym of HTML, and I might think in my brain that the answer for this, the acronym of the HTML is Hypertext Management Language. And it is incorrect, as you can see. The correct answer is Hypertext Markup Language. Well, who was the founder of C++? And let's assume that I know this information, and that's why I'm going to select the correct answer. Bjarne Stroustrup. Then finally, what is the first programming language? Let's say that I assume that the first programming language is JavaScript for some otherworldly reasons. And correct answer is Fortran, and my performance was very bad, as you can see. Now let's try to answer all the questions correctly in order to feel a sense of satisfaction. So C, then Google, then Hypertext Markup Language, then Bjarne Stroustrup, then finally Fortran. And my result is still what? Correct count. My bad. Once again, clear C, Google, 1, 4, then Fortran. Now my performance is brilliant, 5 out of 5. And this is how you implement a typical quiz application in Python programming language, by following all the best practices and writing clean, organized code. This section is going to be extremely straightforward, in which we will create a simple palindrome checker function. So let's create a separate folder and implement our program real quick without spending too much time on it. So palindrome checker. So palindrome is basically a word that reads the same backward and forward. So let's create is palindrome function, which receives a text and returns a boolean, whether it is palindrome or not. So to check that, we can implement that functionality in one line, in a single line. We can just say text does this and -1, which basically reverses the text, and if that equals to the original text, we'll return true, otherwise we'll return false. Then let's take some kind of input from the user to check that string, whether it is palindrome or not. So text, maybe text, yeah, text input, enter a string to check, maybe like that. Then if is palindrome text, I will say print f text is palindrome, like that. Else print text is not palindrome, and I'm missing a f here at the beginning. Now this should be working fine. Let's try to run it. cd009 python main.py, enter a string to check, for example noon, and that is palindrome. Then race car, it is palindrome, and let's enter in some kind of garbage, and it is going to say that this string is not palindrome, which helps us validate that our program is working very fine. So this is how you implement a simple, extremely straightforward palindrome checker application in Python. So the last project is gonna be a simple word counter application. The user will select a file and we'll have to count the number of words in that specific file. So let's go ahead and create a separate folder here and call it 10 word counter. And inside of that, let's create a Python file that is going to count the number of words in that file. So main is going to be main function, and let's create our if block here, if name equals to main, then pass, not pass, but call our main function. In our main function, we'll get the name of the file from the user by using input, enter the name of the file, something like that. Then we'll say try, and we'll try to open that file and read content of that file. If that file does not exist, it is going to subsequently raise an error which we want to handle gracefully. So open file name as in a reader mode as file, then word count equals to 0 initially, then for line in file, then word count plus equals to len of line, that's strip. Strip is useful in order to strip all the unnecessary white spaces and new line characters at the end of the line. Then I want to split this into, maybe this strip is not necessary here. Split is going to account for that issue as well. It is going to split all the white spaces and new line characters, tabulations, etc. And it is going to return a valid list of all the words in my line. And I'm basically counting the number of words in that specific line. Then except I'm gonna say print invalid file name, and that's it. I think, yeah. And I have this here print number of words, the resulting output that I get, the number of words in file name, and word count, like that. Then let's create our text file, which is going to contain approximately 20 words. And instead of typing those words out manually, I'm going to create an index.html file, and we'll use some cool tricks. So index.html, and index.html file supports such lorem ipsum random word generator functionality in VS Code. So if we can say lorem 20, and it is going to generate it is going to give us the first 20 words of the lorem ipsum kind of text, which is, in my opinion, has been written in Latin. So lorem ipsum 20, and if I copy it, it is going to give me exactly 20 words. So I can space them out nicely into different lines, and I got 3 lines in total. So I can close that and close that index.html as well. And now let's try to run this application, python main.py, and it should give us 20 words as a result. Text.txt is going to be the name of our file, and we have 20 words, as you can see here. If we were to delete one word from here, for example, these 3 words, and if we try to run it one more time, it should give us like 17, yeah, 17. And if we were to go ahead and create lorem and 50, for example, maybe 60, and copy them all, paste them here, and if we were to try to run our application one more time, text.txt, it should give us how many? 65? 60, yeah, because I've specified 60 words here. So yeah, this is how you implement a simple word counter application in Python. By the way, if you were to specify some invalid file name, it would give us that error message saying invalid file name and invalid file name, as you can see here. So this is kind of relatively safe, simple word counter application in Python programming language. And that's it. We've successfully built all 10 hands-on Python projects for beginners. I hope you enjoyed the video and learned something new today. If you did, please give this video a like and don't forget to subscribe to the channel for more programming tutorials and projects. Thank you so much for watching and I'll see you in the next one.